Hello, thank you for watching this video. So in this video we're doing question 5 of May, June 2024 question paper mathematics paper 1. The topic is functions. I have the exponential function and this inverse here. So let's go. They are saying in the diagram, the graph of f and g are drawn. G is a reflection of f about the line y is equal to x. Graph G passes through the point P. Q is the x-intercept of f and R is the y-intercept of G. So let's look at this. They are saying you are given two functions, the function of f and g. So here's f and here's g. And the equation of f is in this form, right? Log ax. So it's log x base a. So isn't it? Are you familiar with logs?
Log base.
Is it log x base a?
Yeah.
Okay. So this thing is f of x equal to log x base a. Right? No problem. So this one, this red function f is this log function here, which is, yeah, this is a log function. And g is an exponential function. That's what you have. No problem. So what are they saying? They are telling you now that g, which is this exponential function here, is a reflection about this line here. So what is a reflection? You know, when you look in the mirror, you're looking at your reflection, right? Which means if line y is equal to x is a straight line with a gradient of 1 and the y-intercept of 0, that it passes through the origin. If you were to plot this straight line, the x-intercept and the y-intercept are there. So is this straight line here? It's a reflection about this line. So what they're saying is that if you were to take a mirror and put it here and look at this function at this point, it will look exactly like that on the mirror. Because if you're looking at the mirror, looking at yourself, you see yourself looking the other direction. You're looking to your left, right? And you're inside the mirror, you'll be looking into the right. That's what will be happening. So this is the line y is equal to x here, right? So this is the line where we put our mirror. So if you are reflecting about the y-axis, about the line y is equal to x, the mirror, you'll put it along the straight line y is equal to x. So it will sit there. So what you will see on the other side, if you're looking at the mirror like this, you put a mirror here, what you will see is this graph having a shape similar to that one. That's what you do. If you reflect about the y-axis, these are the y-axis. It's more like the mirror will be put here, right? So what will happen is this side will be appearing to that way and this one to maybe that way. So that's what you do when you reflect. Imagine putting a mirror there and see what you find. Right? No problem. So, and then they went on to say that your function f, which is the red function, passes at point P. There it is. It passes this point P, which is its coordinates 4 and 2. And Q is the y-intercept of f, and R is the Q is the x-intercept of f, and R is the y-intercept of G. Done. No problem. So we'll go to the first question, which is 5.1. What are they saying at 5.1? At 5.1, they're saying write the coordinates of P prime, the image of P on G. So they want you to write the coordinates of P prime, right? What is this P prime? It's the image of P in what? In G. That's what they're saying. So they're saying you have P here, right? If you are reflecting about this line, where will this position be on this new function here? Because I said this function is formed by putting a mirror like this here, right? So what you will see here, which will have this shape like this. So if you have this question paper, get yourself a mirror and put a mirror here. You will see this shape will exactly be similar to this one. That's what we will see. So now they're saying if this point P is 4 and 2 at F, what will it be on G? That's what they are asking. So in order to be able to answer this, you need to know your transformation about reflecting light about line is equal to x. So if you reflect about line y is equal to x, right? You apply this transformation. Your x and y coordinates on the original function will swap around and become y and x coordinate on the new function. So this is the image. This is P, this will be the image of P. So what does this mean? It means that if you have your P with the coordinates of 4 and 2, if you want the image of P, these will swap around, so it will be 2 and 4. These will be the coordinates of P. And you're done with it. You just need to know the transformation is this for reflection about the line y is equal to x. And you're done. We're done then. So we'll go to the next one, which is 5.2. What are they saying? They're saying show that a is equal to 2, right? They're saying show a is equal to 2. What is a? A is the value of this log function here. So we got that f of x is equal to log a log x base a, right? So they want us to find the value of a. In order to be able to do this, you need at least one point on the function f, so that you can put the x value there and the y value there. So that you can put the y value here and the x value here, so that you're left with one unknown. Right? That's what we need to do. So is there any point that we have on f? Yes, there is. P is the point on f. And P have the coordinates 4 and 2. So this is your x and this is your y. So substitute y there and substitute your x there. So what you will have, we said we have f of x is equal to log x base 2. So our f of x is y, which is 2. Our x is 4. So what we have, you substitute your y there, which is your 2. So you have 2 is equal to log x. What is your x? Your x is 4 base a, which is what you're trying to find. If you have log 4 base a, this is equal to log 4 divided by log a. This is equal to this. So what you have now, we have 2 is equal to log 4, essentially, over log a. That's what you have. Then you cross multiply over 1. This times this is 2 log a. This is 2 log a, right? Is equal to log 4. So if you have something multiplying a log, which means this thing was originally from here. So you take it back to where it's coming from. So this is log a raised 2 is equal to log 4. So this log is this. If you're saying this is equal to this, you're saying these things are the same. So you can say log is the same as the log, which means this should be exactly the same as that. So your a squared should exactly be the same as what? As 4. Which your a squared is equal to 2 raised 2. Right? So if you're saying a squared is equal to 2 raised 2, you're saying these two things are exactly the same. You can see the exponents are exactly the same, which means your a should be the same as 2. So your a is equal to 2. We've shown that, which is what they want us to do. And we're done here. We go to the next one, which is 5.3. So, what are they saying at 5.3? At 5.3, they're saying write down the equation of g in the form y is equal to. So they want us to write down the equation of g, this exponential equation. So where do you take it? You take it here. Here is it. It's this point here. It's y is equal to this part here. So the equation for g of x is equal to a raised x. A raised x. And your a is what? Is 2. Because you just proved that a is equal to 2. So which means your g of x is equal to 2 raised x. That is your equation for g. Easy, right? No problem. Now we're going to 5.4. What are they saying in 5.4? They're saying t is a point on f, right? It's told that t is a point on f. Here is f here. No problem. T is a point on f. Okay. T is a point on f in the first quadrant, where TR is parallel to the x-axis. Calculate the area of triangle PRTP prime. No problem. They're saying T is a point on F, so T is a point on F, here is F here. Right? No problem. And then they went on to say, T is a point on F in the first quadrant. So T should be here on the first quadrant, on F. It lies on F. Fine. Where TR is parallel to the x-axis. So when you join T and R, they are joined by a horizontal line. Right? Because T is on F. Let's say T is here. Because TR, if you have T here, TR is parallel to what? TR is parallel to the x-axis. Because this is R, this is T. So this line, this blue line, is TR here. So the coordinates for T is X and Y. You don't know what X is, right? But I think you know what Y is. Y is the same as that one over there. At R. And you know at R, your Y is equal to 1. The coordinates of R is 0 and 1. Because you can find them here. Because this is the equation of G, which is that equation there. If you want the coordinates of R, you know Y is 0 there, right? You know that your Y is equal to 0. At point R, X is 0. Because along that line, X is 0. So your coordinates for R will say will look like something like 0 and Y. Right? So you substitute your X there to find your Y. So G at 0 is equal to 2 raised 0, which is equal to 1. So the coordinates of R is 0 and 1, which is what I'm saying there. So these are the coordinates of R, is 0 and 1. There we have them, 0 and 1. Right? No problem. So if R and the point T that lies on F are parallel to the x-axis, so they lie on the same line. So the coordinates for T, the y coordinate does not change, because if you look at this here, along the horizontal line, this horizontal line, which is the x-axis, your y remains unchanged. Even on the horizontal, so a parallel line, a line parallel to the x-axis will also be horizontal. So its equation will be y is equal to 1. There is it. Actually, its equation is y is equal to 1, so it's that horizontal line. It's similar to this one here. But this one is 0 because it's passing through 0, but this one is passing through 1. No problem. What are they saying? They are saying now, T is a point on F in the first quadrant. There is T, right? Because TR is parallel to the y-axis. So they have the same orientation. No problem. They are saying now, calculate the area. So they want you to find, at 5.4, they want the area of what? Of triangle RTP prime. So here is R, here is T. What you're missing is P prime. But we did find the coordinates of P prime to be 2 and 4. Right? We did find the coordinates of P prime to be 2 and 4. So the coordinates of P prime is 2 and 4. So here's what we can do actually. We can go and find first the coordinates of T, so that we can have the coordinates of R and have the coordinates of T, and now we also have the coordinates of P. So T lie on this function here. So on the function T lie on the function f, right? On f of x is equal to log x base 2. So here is the equation of f. So here's the equation of f. So we have the y coordinate to be 1. So we're missing the x value. Let's go and find that x value. So what are we going to do? So okay, f of x is equal to log x base 2, right? So the y value, what is the y value? The y value, we have it there, it's 1. So we substitute 1 here is equal to log x base 2. So 1 the value of x. How are we going to do this? I said this is equal to log x over log 2. Same way we did here. Then you cross multiply. So 1 is equal to log x over log 2. Cross multiply over 1. So log x is equal to log 2. So if you're saying they're equal, they're identical, which is log is the same as log, so your x should be 2. The x should be equal to 2. So we have the x coordinate of this point to be 2. These are the coordinates of t. Then p prime was 2n minus 4. So which means 2, p is directly above this point here. So it should be, if this is 2 here, so 2 and 4 should be a point maybe somewhere here on this line. This point there. So you want the area of triangle R, P prime, and this thing here. If you can see this is a 90-degree line. Right? This is 90 degrees. So the area of the triangle, so area of the triangle is called to half base times the perpendicular height. So area of triangle what? Triangle R what? RTP prime is equal to half. What is your base? Your base is the length of this distance here from 0 to 2. So it's 2 units times the perpendicular height. What is the perpendicular height? Starting from 1 up to that point 4 there, right? Because we said the coordinates of P is 2 and 4. So the perpendicular height is what? Is 3 units. So it should be half of 2 times 3. So your area should be equal to the answer of this, which is equal to 3 square units. So I think the area of this triangle is 3. And you're done here. And I hope it does make sense to you, as it does to me. Thank you for watching. Let's go to the next question. Cheers.